Hello, welcome to my video about YDLiDAR G4. This is a LiDAR that is manufactured in China, Shenzhen, by Shenzhen Yuedang Technology, and this is very useful in robotics. So one thing is that in robotics you want to measure distances from the robot to obstacles to the next things around in the environment. And to measure distances, you can use ultrasonic sensors, for instance. This is common. You can also use infrared sensors, and that is a very close proximity. And you can also use radar. This is used in autonomous cars. And there are also depth measurements that are obtained using by using stereo cameras, for instance, or cameras with neural networks for depth estimation. These are some of the techniques. But one of the indispensable, at least so far, or common techniques for measuring distances in robotics is LiDAR. Some people say LiDAR. I say LiDAR. Sometimes I say LiDAR. But the thing is, this is light detection and ranging, LiDAR. And in this particular video, we're just going to connect this LiDAR to Windows and get a Windows app to view the point cloud. And in the next video, we're going to do this same configuration, but on Ubuntu. Because in Ubuntu, we can use ROS, Robot Operating System. And with ROS, you can do a lot more things now in building up a robot. And that's what we will do. We will build up a robot with ROS, and this will perform simultaneous localization and mapping, SLAM. So without further ado, let's unbox this LiDAR and connect it and see the point cloud and see its limitations and all that. So opening it, first thing you see is, of course, the text is in Chinese. It's from Shenzhen, China. But the website has a lot of support in English, so do not worry. Plus, this video, of course, also provides you with some information on how to use it, so don't worry. First thing you see is USB hub, some connector that has power and data on one side. So the data is through USB-C and the power is through micro USB. And the other side has a serial connection that connects the LiDAR itself. It has, the first is motor control signal, and then it has ground signal, TX signal, RX signal, 5 volts. So that's the serial connection. And the main piece, so this is $320 as of today, the 3rd of September 2020. And so this is the serial that has to be connected to the USB hub on this side. And without further ado, let's connect it. There is no need to be very careful as I am doing right now, because it's self-evident which direction it goes. And so just plug it in and connect the data on the USB-C. And then connect the power on the micro USB. So LiDAR to the USB hub or USB splitter, and then from the USB splitter, you have one that goes to your computer through the USB-C. This is for the data. So plug it into your Windows computer there. And as you can see, it spins a little bit just after plugging in the data. And this other cable is the one for the power. And so I connected it to an external adapter that is able to supply a bit more current. I think this is about 2.2 amps. So this other one is for the data that I already connected in. With the connection to the power, we can now go to the Windows computer and see what we need to run the LiDAR and see the point cloud. So first thing, go to YDLiDAR website. This will give you some of the applications that you need to run the YDLiDAR. And As I said, I'm using YDLiDAR G4, and so I have to choose the correct model for my usage, which is YDLiDAR G4, as you can see here. Choose that and go to the tools. So one of the things that this will give you is a download for the point cloud viewer. And also scroll down below the page, you see drivers for the USB. So USB adapter board driver. So this is for the USB hub that you saw in the connections. I download that too. And when the downloads are done, you go and extract the USB drivers. That's the first thing. So USB drivers, extract, and go to the extracted folder, which shows CP210X. This installer for 64-bit. That's what I use for my computer. Next, finish, and now you have the drivers installed, CP210X. You will see it later on. And now extract the point cloud viewer and go to the folder. This is a client application you use to view the point cloud. And so let's open the point cloud viewer and see how it will connect the USB and eventually read the values from the LiDAR. So when you open it, you see it's in Chinese. Of course, there's a COM port, there's the specific model of your LiDAR. You change the language to English, simple. And now you have to know the COM port. So the COM port, you have to go to your device manager and see under your devices what COM port the LiDAR is connected to. You're looking for under ports, you're looking for CP210X, as you noticed earlier when we installed the driver, so which is USB to UART bridge. So COM port 5 is the one we're looking for. So we go to COM port 5 and we choose the specific model, which is G4 in our case. Click OK, and it brings you to the point cloud viewer. So you'll be seeing the angles, you'll be seeing the distances as shown by the rings in the point cloud viewer. And in the corner here, you can see the numeric values for the angle and for the distance right here. So there's several buttons on top. One of the key ones, of course, is the play button, because this is the button that you use. This one right here is the one that you use to start the LiDAR. And so when you click it, it starts connecting to the LiDAR, and now you can see it's spinning. And on the other screen on the left, you can see the point cloud for the room. And so going to my other screen, let's see what other functionalities you have on the screen using the mouse. So this is the point cloud. First of all, you can see there's a way in which you can zoom in and zoom out by using the scroll wheel on your mouse. So notice that I'm scrolling and this is zooming in and zooming out. Right, so, and you can also see a few other things like the radio lines showing the distance. You can hold the left mouse button and move the cursor to move the entire map on the screen. So these are some of the few things you can try out. And notice this corner in my room. There's this peculiar corner. It's the bookshelf right there, and there's a wall in a corner, and so that can be seen in the point cloud. And this part right here is me sitting next to the LiDAR, very close to the center of the concentric circles. On the other side is a wall. This wall that you see here is represented by the other flag that you see here. And the red line that you see on the screen that moves with the cursor, that is able to give you distance to the and angle the indicated object. For instance, the corner of the bookshelf right here, if I was to place this red line and point point it at the corner of the bookshelf. And we can see the angle at which the bookshelf is 204 degrees, and we can as well see the distance. That the corner of the bookshelf is from the center of the LiDAR. So right now it's showing it's about 2.77 meters from the center of the LiDAR. And I can verify that with a distance measuring device. So this is a laser pointing device from Bosch that we can use to verify this 2.77 meters. Okay, so the distance from the LiDAR is measured from the center of the LiDAR. So we have to ensure that we place the end part of the tool right at the center of the LiDAR. So this end right here has to match up with the center of the LiDAR for us to verify the 2.77 meters. And we have to point the laser light right at the corner of the bookshelf. So we ensure the center is matching with the end of the laser device, and we point. And when we get that value right, let me focus. So we focus it to the corner of the bookshelf right there, and hold the value. Let's see, 2.75 meters. So of course I was moving around. There's some error, that, but 2.75 meters and 2.77 meters. That's the difference is just in the millimeters, about a centimeter or so, but that is within some error. So let's try this other side. We try the flat side of my room, the wall next to the door. So in the right screen you can see we're right there where there's the door. The door is this small bulge there, and so next to the door next to the door we have the flat wall, and so we focus our cursor there so that the LiDAR gives us the value at that part of the wall, and it says it's 2.22 meters. Right there, you can see it, 2.22 meters in the left part of my screen, right there. So let's verify 2.22 by using the other ranging device. We align the center of the LiDAR with the end of the other ranging device, and point the laser beam at the wall, and lock in. Let's see the result. That's 2.24 meters. So this is within, I think, reasonable bounds, considering that I'm moving my hands and all that, but it still matches reasonably with the 2.22 meters. Alright, so to know where the zero reference is, this cable on the LiDAR points to the 0 point. So I can move the LiDAR around, and you can see the map on the screen is moving too. And the 0 reference point for the LiDAR is along this cable right here. So this is the 0 degrees. And if I align this 0 degrees with the longitudinal or the longer side of my room, you see how the 0 matches or aligns with the room. So that's me right there, and that's me in the map. And let me align the LiDAR's 0 axis with the lengthy side of the room. Aligning it with the longer side, along the length of my bed or my room, the longer side. And so you can see on the screens that the map is also aligned in that direction, because the 0 degrees of the LiDAR is along the cable of the LiDAR. You can verify this from the datasheet and others. So if I move it around again, you can see it's moving in the opposite direction, which is making sense. You move the LiDAR clockwise, the map should move counterclockwise, at least in the display, in this Windows display. All right. So the next thing is we have to also make sure we see what's the minimum distance, what's the maximum distance. According to the datasheet, the maximum distance is 16 meters. And the minimum is something I had to test here. My LiDAR stops registering obstacles when the obstacle is about 26 centimeters from the LiDAR. So the red line points at the book right now. I'm moving the book towards and further away from the LiDAR. So when I move closer, notice in the screen, it stops registering at 26 centimeters right there. It becomes sparse, and when I start moving away, it again starts registering the obstacle. So 26 centimeters is the minimum, 16 meters is the maximum. And stopping it, you just click the stop button and it stops spinning. So next is we're going to use it in Linux, Ubuntu, and that will enable us to use ROS and develop further on that. Thank you.